Okay, so let's get started. So many of you would have taken the basic session of arrays and vectors. Today we would be covering some advanced concepts and some questions that may have that have come in many interviews. Obviously, all the questions do not repeat, but the concept that we would be studying is important and can be used to solve many problems. So let's get started with the problems. In the advanced session we would not be studying about any concepts. We would be doing problems and understanding how the problems can be done. Let's get started. So the first problem is search in a rotated sorted array. So what is the problem? The problem is you would be given an integer array, and that integer array would be sorted in ascending order. 1 minute. Yeah. And that integer array would be sorted in ascending order, and you would be given an integer target. Then what would happen is the question would be that in that array, that array is somehow rotated, and what you have to do is you have to search for an element in that array. For example, the array is 0 1 2 4 5 6 7. As you can see that this array is sorted, right? Now what happens is the question says then this array is rotated. So they take some element, for example 4, and after 4 what they do is this 4 5 6 7, this part of the array they paste it right in front of 0 1 and 2. So as you can see, if we start from here 0, we can see 0 1 2 4 5 6 7. This array is sorted, but it is rotated, right? So now what we have to do is, the question is, in this sorted rotated array, I would give you like I want you to find that if the element 4 is present in this array or not. If the element is present, return the index of the array. Otherwise you have to return that -1, which means that this element does not exist in the array. For example, if I want you to search 3 in this array, you would obviously return -1 because 3 does not exist in this array. So let's see how we would approach this problem. Okay, so first of all, what I think every one of you should do is, whenever such a complex problem is given, you should always visualize it. So first of all, we would visualize how this problem would look, and after visualizing it, we will see what we can do. So if we in this problem we can actually plot a graph. As you can see, here on the x-axis there are indices, and on the y-axis there are values that are present at each index. On the fourth index, the value is 1. On the fifth index, the value is 2. On the sixth index, the value is 3. And on the seventh index, the value is 4th. After that, you can see here on the first index, the 0th index, the value is 5. Then on first index, value is 6. Second index value is 7, and third index value is 8. As you can see, this is the graphical representation of a sorted rotated array. Uh, so did you get it? How I have graphically represented it? Is there any confusion in it? Is there any confusion? Okay, if there is no confusion, okay. So
Sorry to disturb you. Can you explain this again, please?
okay, I will show you 1 minute. As you can, oh, okay. So as you can see, for example, the array I gave you is 5, 6, 7, 8. And then after that, the array 1, 2, 3, 4. 5, 6, 7, 8, 1, 2, 3, 4 is the array. then what you can see is this array is sorted but rotated. What I mean is 5, 6, 7, 8 comes before 1, 2, 3, 4. If we put 5, 6, 7, 8 after 1, 2, 3, 4, the array would be sorted completely, right? So that's why what I have done here is, if I plot the indices on the x-axis and the values on the y-axis, what I will see is on the 0th index, the 5 is there. On the first index, 6 is there. On the on the second index, 7 is there. And on the third index, 8 is there. So 5, 6, 7, 8 are on the first four indices, and 1, 2, 3, 4 are on the next four indices. 4, 5, 6, 7. 1, 2, 3, 4 are on 4, 5, 6, 7. That's what I mean. Okay, so I will show you here also. See, if this is a sorted array 1, 2, 3, 4, 5. So if I take these 4 and 5 and put it before 1, 2, and 3, the sorted rotated array would become 4, 5, 1, 2, 3. Am I right? Then, if we are told that 4, 5, 1, 2, 3, and this 4, 5, 1, 2, 3 can be represented here also. For example, if I want to represent 4, 5, 1, 2, 3, wait, see, if I want to represent 4, 5, 1, 2, 3, then what I can do here is, this is the 0th index, this is the first index, this is the second index, this is the third index, fourth index. Okay, and here are the values 1, 2, 3, 4, and 5. Okay, so if 5, 4, 1, 2, 3 is there, so how, if the is, if the array is 4, 5, 1, 2, 3, right? So what we will do is 4 will come at the 0th index, so I will mark it like this. 5 would come at the first index, I would mark it like this, and I will join these 2 points. Then after 4 and 5 are done, then there comes the value 1. Then value 1 would come at the second index, so I will mark it like here. Then 2 will come at third index, I will mark it here. And then 3 would come at the fourth index, I would mark it here. Then I will join these 3 points, and it would become like this. So is there any problem? Whoever asked it, is it clear now, or should I explain again?
No, it's clear. Thank you.
Okay. Okay. So this is how. Now think about it. If this was a sorted array, how would you search for an element in an array? There are two things you can do. Either you can do a linear search, right? You can go to every element and check if uh, that element is the element you are looking for, right? Or and that's what you can do in this question also. That is also an option. You can go to every element and check if that element is present, and in what index that element is present, and return that index. You can do that here also, but that is not an optimized method. The second thing you can do here is, what you can do is you can really just sort the array using the sort function, and then you can so search in this thing using binary search. And how many of you know binary search? Is there anyone who doesn't know binary search? Just tell me, I will explain that too, if there is anyone who doesn't know binary search. Is there anyone who doesn't know binary search? Okay, so I take it that everyone knows what is binary search. So what we can do is, we can sort this array, and we can just using binary search we can find the element. And what binary search is, we will take up a mid element, and if the key that we are looking for is less than if the key is less than the mid element, then we will look into the left part of the array. If the key is greater than the mid element, then we will look in the right part of the array. That's binary search. Okay, so now what I want you to think about is, can we use binary search in this question? Just think about it. Okay, so is there anyone who would like to say something or who has any approach that they can use for this question?
We can't use binary search.
Okay, we can't use binary search. Pallavi says we can't use. Anyone else who has any other opinion about this? Okay, so let's move on. I will tell you guys. We would actually, Pallavi, if you think about it, you can see here that the array from 0 to fourth part, 0 to third index is sorted, and from fourth to seventh index, this is also sorted. So we can use binary search on 0 to 3, right? We can also use binary search on 4 to 7. It is possible, right? We can use binary search on two different parts of the array and we can find the element. Okay.
Yes, ma'am.
Okay, so this is possible, but the thing is, we that won't be that much efficient. Like, you would be trying to do binary search here, then you would be trying to do binary search there. First you have to uh, look for the element after which the array is rotated. That won't be that much efficient. So what we are gonna do is this. See, so as I had told you earlier, this is the, suppose this is some, there is some array, and this is the graphical representation of this array. So what can happen is, for example, this is this 1 2 3 4 5. This sorted ordered array is 4 5 1 2 3. Okay, so if, let's try using binary search. So the midpoint of this array would be at index 2, 0 plus the midpoint is at index 2, 4 5 1. That is 1 is the midpoint here, right? So our point can lie on either side of this midpoint. Okay, we don't know actually where would our element lie. So maybe it is on the left side, maybe it is on the right side. Since the array is sorted, rotated, we don't know on which side our array is. Maybe it's on the left side, maybe it's on the right side. So what we can do is, there are two cases. Suppose this is the graphical representation of the array. 1 minute. Suppose this is the graphical representation of the array. So now there are two cases. First case is, the midpoint of the element lies on the first line. So what do I mean by the midpoint of the element lies on the first line? For example, if you take this 4 5 1 2 3, the midpoint is 1 here, right? So if we, and it 1 2 3 starts from it's like, wait, I will take the marker. Yeah, so it is 4 5 1 2 3. 1 2, yeah, here the 1 2 and 3, these elements lies here, and 4 and 5 lies somewhere here. The values, there are the indices, the values, 4 5 lies here, and 1 2 3 lies on this line. Is this clear, right? So when these values lie here, what we can see here is, the 1 lies on the lower line. 1 is here on the lower line. Okay, so but it may be the case that there was one more element here, like the array was supposedly 1 2 3 4 5 6 and 7. Suppose this was the array, then what would happen is, the midpoint would be 1. The midpoint of this array would be at 1. according to binary search, start plus end by 2, and this one would lie on the upper, in this part, on the upper line. Okay, so this one would lie here only. So when this happens, there are two cases, that the midpoint lies, maybe it lies here, the midpoint maybe it lies here. So these are the two cases, that it can lie on the first line, or either it can lie on the second line. Okay, so how do we know where is the midpoint line? So we can see that if, as you can see here, this is supposedly ARR of 0, ARR of 0, which is ARR of starting. There are, we take three indexes: starting, this is the end index, and here what wherever we find is the middle index, right? So what we can see here is, if ARR of mid, let's take the first case first, that the mid element lies on the upper line. So when the mid element is lying on the upper line, you can see here that if ARR of S is less than key, is less than ARR of mid. Okay, what do we mean by it? For example, this is the value of ARR of S. This is the value, this is the value for ARR of mid. Okay, and supposedly your key that you want to find maybe supposedly lies somewhere here. Okay, so if you see that this part is sorted, right? When this part is sorted, you can see here that ARR of starting is less than key, right? And key is less than ARR of mid. So this means that your element lies here. Okay, so you would call that function again on this smaller function, and this smaller function is actually nothing but a similar problem that we were doing recently but on a smaller scale. So we can see here that this thing will come here only. Now suppose what happens now is that your key doesn't lie here. Your key lies on the first line, but your key lies here after the midpoint. Now what would happen is, when your key is lying after the midpoint, you will search again in the right part. Now means your start will become mid plus 1, and you will call that function again, but you will call that function on a smaller scale. So here you are calling that function again, but on a smaller scale. As you can see here is, if we plot the graph again of the smaller problem, it would be something like this. Right? It becomes a similar problem, and your key lies here. Then again you find mid. Suppose your mid now lies here on the second line. So now you can see, when the upper line becomes small, now your mid will lie in the second line. So when your mid is lying on the second line, that means this becomes the case 2. So what happens when your mid lies on the second line? So your mid lies here on the second line. This is the midpoint. Okay, this is the end of the array, this part, and here, okay, and this is the starting index. And suppose now what happens is that the key or target that you're trying to find is somewhere here. So what you can see here is that this thing is sorted, right? The second line is sorted, the second part is sorted. So what we can see here is that the ARR of mid is less than key, and key is less than ARR of end. The ARR of mid is less than key, and key is less than ARR of end. So what we will do is, we will make start mid plus 1, and we will search in the right part. Okay, and supposedly if our key does not lie here. If our key lies somewhere here on the second line, but here, or maybe it lies in the first line, we don't know. Maybe it lies in the first line, like in this case that we did, right? So maybe our key lies here. Then what we will do is we will make our end mid minus 1 and we will search in the first part. And this is nothing but again a smaller problem, but a similar problem, but on a smaller scale. What we are doing is we are just making our start mid plus 1 or our end mid minus 1 based on certain conditions. And then we are calling the function again recursively. This is what we are doing in this question. So I will recap it again for you. What we are doing is, for example, your the key that you are trying to find is 6, right? And the 6 is lying on the upper part, and you found the mid. The midpoint lies here somewhere, and then you will just look that if AR of start is less than key is less than mid, then it means it is somewhere here. Then you make end equals mid minus 1, and then you search for that thing here in the left part. Suppose you're trying to find 3, you will first check that uh, if ARR of start is less than ARR of mid, which means if the mid is lying on this plane, this part here, and start is less than mid, then you will check that if ARR of start is less than key is now here, and the key, it is not less than key, so we will search in the right part. Is it clear to everyone, or should I explain again? Is it clear?
Please explain again. And if we are given the even numbers, then how we will find the mid number also?
Mid is nothing but your start index plus end index by 2. For example, there are even numbers. For example, 1 2 3 4 5 6 7 8. These are even numbers, right? So your starting index is 0, your ending index is 7, and you're doing 7 by 2. 7 by 2 is nothing but 3. In coding language, as you can see that 7 by 2 will give the floor of that thing, so it is 3, nothing but 3. So the third index would be the mid index. So 0 1 2, for example, 5 6 7 8 1 2 3 and 4. So as you can see here is the first index is 0 and the last index is 7. So you would do 0 plus 7 by 2, which is third index. So 0, 1, 2 and 3. So 8 is the midpoint. This is how we will calculate the midpoint. And then we will check if ARR of start is less than ARR of mid. If it is small, then the midpoint lies on the first upper line. If it is ARR of start is greater, for example, here it was instead of 8, it was 0, suppose, then 5 is not less than 0, right? Then it means mid lies on the second line. 0 1 2 3 0 1 2 3 4. See, 0 1 2 3 4 5 6 7. 0 1 2 3 4 on the lower line, 5 6 7 on the upper line. If it is 0 and ARR of starting is less than ARR of mid, it means mid lies on the second line. And if mid lies on the second line, then you will check if ARR of mid is less than certain key and it is less than ARR of end, key is less than ARR of end, it means it lies in the right part. So you will search in right part. If this is not the case, then you will that means your key is lying somewhere here or maybe somewhere here. So you will search in the left part, and this will be nothing but a similar problem but on a smaller scale. That's all we are doing. First, we will be checking if ARR of S is less than ARR of mid. This is the condition to check if it is the upper line or if it is the lower line. If it is the upper, if ARR of starting is less than ARR of mid, it is the upper line. If it is false, it means it is the lower line. So if it is the lower line, then you check this condition. If ARR of mid is less than key and key is less than ARR of end, which means that your key lies between the midpoint and the ending, you will search in right part. Otherwise, you will search in left part. Is it clear now?
Yes, ma'am.
Is there anyone else who didn't understand what is happening? Is there any problem? You can unmute yourself if there is any problem, or you can write on the chat. And if there is no problem, just tell me. Okay, so okay, if it is clear, we would move on and we would see an example that we have actually discussed an example. It is 4567012, and we have to find zero. So we will find the midpoint first. There are seven 0 plus 6 by 2, which is 3. The third index is the middle element, which is 7 is the middle element. So here, as you can see, this is the mid equals the third index. Okay, and the starting index is 0, which is the element 4, and the ending index is 6, which is the element 2. Now what we are doing here is we see if that the target is less than the mid element. For example, our target is 0, and 0 is less than mid element, and target is less than the starting element. Then we will move right, that is we will search here only. And that's the same thing that we have done in the previous example. This is just another example. I will share when I share the PPT with you, you can see this. Okay, now talking about the code, let's see how this is coded. So we will start we will start a loop. We will go from start to end. So, and what we will do is we will take the mid element, and the mid element when we take the mid element is actually start plus end by 2. Then we will check if the mid element is the target itself, then we will return the mid element. And then we will check that condition that I was talking about, if this is the first line or this is the second line. This is that condition that we are checking, that if it is the first or the second line. So if nums of start is less than nums of mid, which means the mid element is greater than the starting element, which means it is the upper line. For example, 4567 but of 4567123 array, the 4567, it is the upper line. So if this is the upper line, then we will check if our target lies between the starting point and the midpoint. If it lies between the starting point and midpoint, then we will make end is equals to mid minus 1. If it does not lies between the starting and the midpoint, then it means it is present somewhere in the right part. Then we will make start is equals to mid plus 1. The second thing is if it lies in the lower line, which means nums of mid is less than equals to num of end, right? It is lying in the lower line. When it is lying in the lower line, so we can see here is that the target or the key that we are looking for, if it is greater than the mid element and it is less than the ending element, then we will do start equals mid plus 1. Else we will do end equals mid plus 1. And if we found that element, we would return the mid from here. Since our range is getting smaller and smaller, finally we will reach that element and we will return the mid. If the element is not present, then start will eventually become greater than end, and we will come out of the loop, and then we would return minus 1. Similarly, the Java code is very similar to this one. You can do that yourself. So is the question clear to everyone? Is there any problem in the code?
No, ma'am.
Okay, so let's move to the next question then. The next question is rainwater trapping. So what is the question? Let's see. The question is, you would be given n non-negative integers representing an elevation map where the width of each bar is 1. Compute how much water it can trap after raining. So it's like you are given an array and you have like this. See, as you can see this here, What is happening is, suppose these are the buildings, these are some buildings that are there, and there is some gap between them, and they are of different heights, and it is raining. So what happens is, if there is no drainage system, then the water will fill here, right, in between these two buildings. Then water will also fill here, the water will also fill here. So we have to actually calculate how many units of water is filled between the buildings, and in the array that we are given, those are the heights of the building. The first height of building is 0. The second is 1. The third is 0. Then it is 2. Then it is 1, 0, 1, 4, 2, 0, 2, 1. This was the array. As you can see, this was the array. The heights of the buildings is the array. The height of the building is given, and we have to find out the amount of water that is trapped between the buildings. Okay, so let's try something. Okay, so if I am, suppose I am here, on here, so where the height of the building is 0, and on my left side there is a building of height 1, and on my right side there is a building of height 2. So what you can see, just tell me, what can you what do you what are you getting to know from here? That if on my left building is the height is 1, and on my right building, the height of the right building, the height is 2, then how is the water that is trapped between the two buildings? It is 1. So it is actually the minimum of height of the two buildings. The water is stored, uh, the water stored between the two buildings is the minimum of height of two buildings. Because as you can see, if the water fill was 2, it can't be 2 na, right? Otherwise it will flow off. So that's why the height of the water that is filled between two buildings is the minimum of height of two buildings. So just tell me one thing. If we know the left and right, the height of the left and right building, then can we evaluate what is the height of water of this building that is in the middle of both the buildings? Is it possible? Just look at this graph and tell me, if we know the height of the left building and we know the height of the right building, then is it possible that we can evaluate what is the height of water that is stored between the two buildings? Is it possible?
Yes, ma'am.
Anyone else? Okay, so look, what is, as the situation that I showed you here, it is possible in this situation. But suppose now I am on this position, and the height of my left building is 1, the height of my right building is 1, but still the height of water that is stored above this level is 2. Are you getting my point? The height of left building is 1, the height of right building is 2, but the height of water that is stored above this building, the of height 0, is 2. Why is that? Can anyone tell me why is that the height is 2 here? Okay,
आई गेस जो हाइट ऑफ द एडजेसेंट ब्लॉक है हमें वो चेक करना है एंड अगर हाइट ऑफ द एडजेसेंट ब्लॉक ऑफ दोनों ब्लॉक्स का जो मिनिमम होगा वो हाइट ऑफ वाटर होगी
so you are saying, the instead of checking the height of the left or the height of the right, we would check height, adjacent of left and adjacent of right.
या एंड द मिनिमम ऑफ देम विल बी द हाइट
Okay, so if that's what you think, let's see one more thing here. This case, see this case. Now the height of the left block is 2, the height of right is 2, and the adjacent of left is 3, and the adjacent of right is 3, but still the height above it is 1, 2, 3, 4. It is still not the adjacent. Then what is happening here? It is not adjacent of left and adjacent of right. That was for a particular case. Then what is happening here?
I guess it is the difference between the maximum height of the building till which the water can be retained and the minimum height of the building, the lowest building.
Yeah, it's yeah. See, actually, what is happening is, if you see that, suppose this is the building, that we have to calculate the height of water above this building. So what we can do here is, we can see that what is the largest building to the left of this building, which is the building at the 0th index. Then we can see what is the largest building at the right of this building, which is this building of index n minus 1, index n minus 1, right? Then we will take the minimum of these two. And when we take the minimum of these two, it is this complete height. Not this, it is this complete height. And this complete height, we don't want this complete height. We want the water above the building. So what is it? It is actually the minimum of leftmost largest and rightmost largest minus the height of the building above which we are calculating the height of the water. I will repeat it again. It is actually the minimum of the building, minimum of the leftmost largest building and the rightmost largest building minus the height of the building above which we are calculating the height of the water.
Why we subtracted the last part?
Okay, it's suppose we, if you see here, suppose this is the largest building. This is the second from the left, and this is the largest building from the right. If we take their minimum, it is, what is the minimum of leftmost largest and the rightmost largest? It is the rightmost largest, right?
Yes, ma'am.
So this gives this complete height. But we want water above this building, which means we have to subtract this height to get the water.
Yes, ma'am.
So
Yes,
that's
ma'am.
why
Okay, now
we are
got.
subtracting the height of the building. Is it clear?
Okay, ma'am. Yes, ma'am.
Is it clear to everyone?
Yes.
Can you repeat once again?
Okay, I will repeat it once again. See here. This is the this is the case of the most extreme case that can happen. What is the extreme case that can happen? That first of all, the buildings are in descending order and then the buildings are in ascending order. So what we can see here is, for example, we want to calculate the height of the water above this building. Okay, so what we can see here is, if we take the leftmost largest building and we take the rightmost largest building, then the minimum height of the both the buildings would be the height of the water level, right? Because otherwise it would overflow. If it is the max of leftmost and rightest, then the water would overflow. But if it is the minimum of both of them, then it would not overflow. So height of water would be the minimum of leftmost largest and the rightmost largest. And after that, what we get is the minimum of leftmost largest and the rightmost largest is the rightmost largest in this case. But we don't want the height of rightmost largest. We want the height of water above an ith building. This is an ith building. We want the height of water above it. So we have to subtract the height of that building over which we are calculating the height of the water. So it is minimum of leftmost largest and rightmost largest minus the height of the building over which the height of water is being calculated. Is it clear now?
Yes, D.
Okay, so this is the actually the whole concept. The whole concept is this only. So what we can do is, what we have to actually do is, now for example, the now we have to do something for this case. This is not the extreme case. We can't do simply, we can't do this simply, right? So what we have to do is, what we have to go to first, the zeroth building. On the zeroth building, we would see that, okay, what is the we go to the zero, what is the height of the building on the left thing? There is nothing, so we skip it. We go to the first building, and we see that the height of building to the left of it is 0, and the height of building to the right of it is 0, so we can't store any water above it, right? Then we go to the next building. The height of this building is 0. Then we see that the height of the left building is 1, and the height of the right building is 1, which means the height of the the height of the left building is the leftmost largest is 1, and height of the rightmost largest is 4. And the what is the minimum of that? 1. So we would store 1 unit of water here. Then we would go to this building. Now the leftmost largest become 2, the building itself, and the rightmost largest is still 4. And then we can say that the water stored above it will be minimum of 2 and 4, which is 2 minus height of building minus 2, which is 0, which means no water stored above it. Then we would go to the next building. The height of largest building to its left is still 2, height of largest building to its right is still 4, and we do the minimum of them is 2 minus the height of building, which is 1, hence the water stored above it is 1. Then we go to the next. We would see that the leftmost largest is 2, rightmost largest is 4. The height, then the minimum is 2, and the height of the building is 0. 2 minus 0 is 2. Then the height of water stored above it 2, and we are adding these simultaneously, adding the water that we are getting. But you can see here, what I am doing is, for each index, I am checking the leftmost largest, I am checking the rightmost largest, right? So for each building I am checking. Don't you think this is an expensive process? That for each building I am checking leftmost largest, for each building I am checking rightmost largest. It is a really expensive process. And do you get how the question is going here? That how are we getting the height of water? It is clear, right? Okay.
Yes, ma'am.
So now for each index, I am checking what is leftmost largest, what is rightmost largest. Then I will take their minimum. Then what I will do is, then I will subtract the height of the building itself, ith building from it. That's what I'm doing, right? So now this would be a really expensive process. So as you can see, this is what I told. So water above ith building would be minimum of left of I and right of I, and minus height of ith building. And total water above all the buildings would be summation of this thing, which means summation of all the summation of water above all the buildings. Okay, so what we are doing here is, now finding the highest from left and right for each building would take a lot of time, and it is a really expensive process. We would be find for what we would be doing is, when we are on an index, we would traverse the traverse the indices before it and find the largest there. Then we would traverse the indices after it, we would find the largest there, and then we would do our computations. For every index we would have to do that, right? Otherwise, how would we know what is the largest on the left and what is the largest on the right? So what we can do here is, we can just pre-compute what is the height of largest building to a particular building, so that we can just use these values instantly, rather than going to an index, traversing the left, finding largest, traversing to right, finding largest. For every building, rather than doing that, what we can do is, we can take two arrays. We take a left array, we take a right array. Now let's see what the left array do. So the left array would go, first of all, in the array, it would go here. It would see what is the height of left largest building for this building. It is 0, the height of the building itself, there is nothing on its left. Then let's go to the second building. It sees, okay, now what is the height of largest building to its left? 0 is smaller than 1, so 1. the height of the building itself. Then it goes to this building with a height of 0. So it sees what is the height of the left largest building. It is 1. So it puts 1 in its 1 here. Then we go to next building. We see what is the largest to the left. It is this building itself. 2 is largest, more than any of them, right? So we put a 2 here. Then we go here and we see what is the largest. Is it the height of the building that we are on, 1, or is the uh, or it's the previous largest on the, or is the largest building the largest of the previous building? So we see here the largest is still 2. We put 2 here. Then we go to 0th building. We put 2 here again. Then 2 here. Then we go to this building. We see 4 is larger than 2. We put 4 here. Then comes 2. 2 is larger than 4? No. So we put 4 here. 1 is not larger than 4. 4. 2 is not larger than 4. 1 is not larger than 4. So that's how we compute the left array. So 0.
Ma'am,
Yeah.
but when we are on the fifth one, we will compare it with the previous one. So at the fourth, it won't be 1.
Now, see, what is happening is uh, the leftmost largest for this is 0, right? Because there is nothing there. The
Yes,
leftmost
ma'am.
largest for this is 1, the height of the building itself. So we put 1 here. Then when we go here, what we compare with this with, for example, the height of this building, we compare the height of this building with the left largest of previous building. Wait, I will use the pen. Okay, so the height of
Ma'am,
this
that
building is,
means
so we compare it with 1. Then we come here, the height of this building is 2. So we put 1 here and we compare it with 1. We put 2 here. Okay, now here we come with here at 1. Now we see that this is the height of this building is 1. So then we compare it with this. Are you getting my point? The left
yes,
largest
ma'am.
building, we are comparing this, and the height of this is 0. So we compare it with this. This is how we are going further. We are comparing the height of this building with the left largest of previous building. Okay, and that's how we
Yes,
compute
ma'am, I got.
left array. Yeah. So is there anyone else who did not understand what is happening here? Okay, if everything is clear, then we can see what is happening to the right largest. How can we compute the right largest now? So now to compute the right largest, what we will do is we will traverse the array from the right hand side, from the last of the array. What is the largest? 1. Then we put 1 here. Then what is the largest? The height of the building itself. Then we put 2 here. Then what is the largest? We will compare 1 with 2. 2 is the largest. So we put 2 here. Then it comes 2. Then 2, we compare 2 with 2. So what is the largest? 2 is here. Then there comes 4. Then we compare this 4 with 2 here. So 4 is the largest. So we put 4 here. So similarly, now 4 is the largest. So 4 will come from ahead from this point on. As you can see, it's 1, 0, 1, 2, 0, 1, and 0. So 4 will come here only. So the right array is also clear. We're just doing the same thing, but from the end of the array. That's it. Is it clear? Okay. So now what is happening here is now we have to compute the water stored. So what we have to do is the same thing I told you, the minimum of the left largest and the right largest. So minimum of 0 and 4 is 0, minus height of the building 0, which is 0. Then minimum of 1 and 4, it is 1. Yeah, so minimum of 1 and 4, it is 1, and the height of the building is 1. So 1 and 1 minus 1, which is 0. Then here comes minimum of 1 and 4 again, which is 1, but the height of building is 0. So 1 minus 0 is 1. Okay, then here we come to minimum of 2 and 4. Minimum of 2 and 4 is 2, but the height of building is also 2. So 2 minus 2 is 0. Then we come here, minimum of 2 and 4. Minimum 2 and 4 is 2. Height of building is 1. So 2 minus 1 is equals to 1. And here similarly we go ahead. And after calculating the water stored, we can just add this array up, which is 1 plus 1 2 plus 2 4 plus 1 5 plus 1 6. So total water stored is 6 unit. As you can see here, it is 1 2 3 4 5 and 6. 6 units of water is stored. So is this clear to everyone, or is there any doubt? Is there any doubt? No, right? Should I go on to the code then? If there is any doubt, you can unmute yourself. Okay, let's go to the code then. So this is the similar example that I explained. You can see this when I share the PPT with you. This is here I am storing the left, and here I am storing the right, and then here we are wait yeah. So the left is stored here, and the right is stored here, and this is the water stored above each level, right? So this is what we have been doing. It is that exactly what I explained you. So now let's see the code. What is the code? Okay, so looking at the code, what we will do is we will make two arrays, a left array and a right array. And we will take, if we are using a vector, so the length of the vector is height dot size. And after that, we will see that if n is less than equal to 2, then return 0. Suppose there are two buildings, then two buildings can't store anything, right? At least we need three buildings for storing the water, at least three. So if n is less than equal to 2, return 0 simply. And then we declare a variable trap, and trap is actually the water it is actually the amount of water that we are trapping. Currently it is 0. Okay, after that we declare the first element of left as the height of the left. After that we traverse the the height array, and what we do is we appoint left of I is equals to max of left of I minus 1 and height of I. Okay, so that's what I told you here. Max of left of I minus 1, this is left of I minus 1, and we compare it with height of I. So it is height of I. So we compare it like this: left of I minus 1 and height of I. This is what we are comparing. Whichever is the what is it? Yeah. So whichever is the largest, we put it in the next index of the left array. It is this: left of I is equal to max of left I minus 1 and height of I. Then after that, we make the right array. For making the right array, we traverse from the right hand side. That's what I told you from the end of the array. Height of n minus 1 equals height of n minus 1, and we traverse from the second last index up to the 0th index, and we do right I is equals to max of right I plus 1 and height of I. Max of right I plus 1 and height of I. That's what we compared, right? So we are comparing these, and after that after the left and right arrays have been completed, what we will do is we will just simply put it in the formula that trap is equal to summation of minimum of left eye and right eye minus the height of the ith building, and then we would return the water that has been trapped between the buildings. So is it clear to everyone? Just tell me this. Is the code clear? Okay. Now let's just recall the steps. So whenever you approach a problem, first what you have to do is first you have to visualize the problem statement. So just visualize how you can, if you can visualize the problem statement, you can solve it, because the problem statement is right in front of you and you can see what is happening there. So try to visualize the problem statement and find out what are the extreme cases. Second thing is, just think about how you can approach the problem. Maybe it the worst method that you are using. Maybe it may it be brute force. Don't, it's not like that, if it's a brute force it is the worst. Just think about it, whatever you can do. Just write the brute force solution if you want, and after that just write on your approach on example test case, like what we did, right? We take some example test cases and we just try run our problem. After try running our problem, we will just code it out. After coding it out, if the our code is working, then we will think how we can better optimize our solution. So this is all we have to do, okay? And after these two problems, these are some problems. These are actually the same problems that I have told you today, but modifications of them. So what these problems say is that you're given a sorted rotated array, the same thing that we have done, and we were searching for a number in that array. This is your homework, that what you have to do is you have to search for the minimum element of the array. Instead of searching for any random element, you have to search for the minimum element of the array. And second question is the rainwater trapping problem that we did. You have to make it more efficient. Think about how you can make it more efficient, like reduce its space complexity. Maybe we're using two arrays, right? So like instead of making two arrays, maybe think about how we can use it in a two pointer approach. So that's what you have to do. So these are the just modifications of these two problems, and just try to do it by yourself. Okay. So from here on, Raksha will take the class forward. So Raksha.
So, okay, let's move on to the next question. Okay, I hope my screen is visible. So, is it visible, right?
Yes, it is visible, Raksha.
Okay, perfect. So, this question is kind of easier, yet an important question. Maybe some of us have gone across this question before, and we have this question on GFG2. So some of us might mug up the 2-3 liner code here, but however, this question, if we understand it, it's very important. Why? Because um, the the method and the approach that is used behind this is somewhere used in solving more complex problems that we'll do further in our while studying other DS topics too. So it may sound intimidating first, but it is not. Okay. So let's move on with this problem. This problem is also called Kadin's algorithm. Okay. So basically, what we have to do is we are given an array and we have to find the largest subarray sum here. So, does anyone have an approach like how can we solve this problem? You can unmute yourselves or write in the chat box. Anyone? Just write no idea if you're not able to think of any approach.
Maybe we can try to we take the sum of all the array elements, and then uh, we I guess we can find the sum of we can subtract the initial element and add the next element to find to keep finding the sum of a particular window. We can do this with all window sizes till n.
Okay, okay. So, what would be the time complexity of the code that you suggested?
N square, order of n square.
Yeah. So, yeah, so that was perfectly brute force approach and a nice one. So, what Charanjeev said right now is just traversing every element of the array twice and checking like and finding the largest subarray sum. That's perfectly right. But now let's try optimizing it in big of n approach. So for big of n approach, what we'll do is we'll just take this current sum and max sum. So this max sum will initialize it with the minus infinity value and we'll initialize the current sum with 0. And then we'll only traverse each element of the array once and update our current sum and max sum. Okay, so let's do a dry run. From that, it will be much clearer. Okay. So we have this current sum initialized to 0, max sum initialized to minus infinity, and we have this array. So we can take any other array too. Like if you feel any confusion, so we can take other examples, but let's just try with this one first. Okay. So we have this current sum as we'll just update current sum with array of I, that is the first element, that would be 1. And now we'll check the max sum. We'll treat these two as like boxes or buckets, and we'll update both the variables. Then we'll have max sum and find the max sum would be the maximum of the current sum and the maximum sum that is already there. So out of the minus infinity and 1, the maximum out of these two is 1. So maximum gets updated. Then current sum is not negative and hence it remains 1. Then we go to minus 2. Then on adding 1 and minus 2 it gives minus 1. Then we'll check here. The maximum remains 1. And then this statement gets executed as current sum becomes less than 0. So current sum now becomes 0. Then we'll move on. We have this 3. So we'll update our current sum to 3. Then we have maximum sum as maximum of 1 and 3, which is 3. Then we have current sum less than 0, which is not the case here. So this line does not get executed. Then we have current sum plus array of I, that would be 3 plus 5, that would be 8. Max sum would be maximum of 3 and 8, that would be 8. And our current sum is no longer negative, it's not negative now. So we move on. Now this I becomes equal to n, and hence we have traversed all the elements of the array. So we return the maximum sum, that is 8. And as you can see, the maximum sum in the sub array would be 3, 5, minus 2. Like out of this array, that would be 3 plus 5, 8. Okay. So actually, I hope all of you might be aware of sub array. I just forgot to ask about this. Um, so you're all are aware about sub arrays, right? A quick yes, and a yes if you have understood the problem. Okay, what about others? Guys, please make it a little interactive. Okay. So, okay. So one possible doubt that people face is that will this approach work with negative numbers? Like if our array is filled with all the negative numbers, will this approach work? What do you all think? Will this work? You can unmute yourself or type in will work. Okay, okay. Yeah, it would. Cause every time we have a negative number, our color sum gets updated to 0, and hence if we have a negative number, then the maximum of the negative number gets taken into the account. Okay. So if you have any doubts, you can ask, or this was the last question, a little shorter and a simpler one. Okay, so type in no doubts. We are 20 of us here, and guys, if you have any doubts, just ask, or you can just ask no doubts and we can end with the session. Okay. Mansi, I guess you can stop recording.
Okay, Raksha.